Who's ready to step through the NN MaxPool2D layer? Put your hand up. I've got my hand up, so let's do it together, hey? We've got 7.2. Now, you might have already given this a shot yourself. Stepping through NN MaxPool2D. And this is what I do for a lot of different concepts that I haven't gone through before, is I just write some test code and see what the inputs and outputs are. And so where could we find out about MaxPool2D? Well, of course, we've got the documentation. I'm just going to link this in here. MaxPool2D. In the simplest case, the output value of layer with input size NCHW, output NCHOut, WOut. By the way, this is number of batches, color channels, height, width, and this is the output of that layer. And kernel size, which is a parameter up here, KHKW, can be precisely described as out is going to be the max of some value, depending on the kernel size and the stride. So let's have a look at that in practice. And of course, you can read further through the documentation here. I'll just grab the link for this actually. So it's here. Wonderful. And let's now first try it with our test image that we created above. So just highlight what the test image is. Bunch of random numbers in the same shape as what a single image would be if we were to replicate the image size of the CNN explainer. By the way, we'll have a look at a visual in a second of MaxPool here, but you can go through that on your own time. Let's, if in doubt, code it out. So we're going to print out the original image shape without unsqueezed dimension. Because recall that we had to add an extra dimension to pass it through our conv2D layer. Now, if you're using a later version of PyTorch, you might not get an error if you only use a 3-dimensional image tensor and pass it through a conv layer. So we're going to pass it in test image original shape, test image dot shape. So this is just going to tell us what the line of code in the cell above tells us, but that's fine. I like to make pretty printouts, you know. Test image with unsqueezed dimension. So this is just going to be our test image, and we're going to see what happens when we unsqueeze a dimension. Unsqueeze on the 0th dimension, that is. I was about to say first, but it's the 0th. Now we're going to create a sample NN MaxPool2D layer. Because remember, even layers themselves in torch.nn are models of their own accord. So we can just create a single, this is like creating a single layer model here. We'll set the kernel size equal to 2. And recall, if we go back to CNN Explainer, kernel size equal to 2 results in a 2x2 square, a 2x2 kernel that's going to convolve over our image, like so. And this is an example input and example output. And you can see the operation that MaxPooling does here. So just keep that in mind as we pass some sample data through our MaxPool layer. And now let's pass data through it. Or actually, we'll pass it through just the conv layer first. Through just the conv layer. Because that's sort of how you might stack things. You might put a convolutional layer and then a MaxPool layer on top of that convolutional layer. So test image through conv. We'll create a variable here, equals our conv layer, is going to take as an input our test image dot unsqueeze on the 0th dimension again. Beautiful. Now we're going to print out the shape here. This is just highlighting how I like to troubleshoot things, is I do one step, print the shape, one step, print the shape. See what is happening as our data moves through various layers. So test image through conv.shape. We'll see what our conv layer does to the shape of our data. And then we're going to pass data through the MaxPool layer, which is the layer we created a couple of lines above, this one here. So let's see what happens. Test image through, can't type at the moment, through conv and MaxPool. So quite a long variable name here, but this is to help us avoid confusion of what's going on. So we go test image through conv. So you notice how we're taking the output of our convolutional layer, this here, and we're passing it through our MaxPool layer, which has another typo. Wonderful. And finally, we'll print out the shape after going through conv layer and MaxPool layer. What happens here? So we want test image through conv and MaxPool. Let's see how our MaxPool layer manipulates our test image's shape. You ready? 3, 2, 1, let's go. What do we get? Okay, so we have the test image original shape. Recall that our test image is just a collection of random numbers. And of course, our conv layer is going to be instantiated with random numbers. And MaxPool actually has no parameters. It just takes the maximum of a certain range in a tensor. So when we unsqueeze the test image as the input, we get an extra dimension here. When we pass it through our conv layer, oh, where did this 64 come from? 1, 64, 64, 64. Let's go back up to our conv layer. Do you notice how that we get the 64 there because we changed the out channels value? If we change this back to 10, like what's in the CNN explainer model, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, what do you think will happen there? Well, we get a little highlight here, 10. Then we keep going. I'll just get rid of this extra cell. We don't need to check the version anymore. We'll check the test image shape, still 3, 64, 64. But then as we pass it through the conv layer here, we get a different size now. So it originally had 3 channels as the input for color channels, but we've upscaled it to 10 so that we have 10 hidden units in our layer. And then we have 64, 64. Now, again, these shapes will change if we change the values of what's going on here. So we might put padding to 0. What happens there? Instead of 64, 64, we get 62, 62. And then what happens after we pass it through the conv layer and then through the MaxPool layer? We've got 1, 10, 64, 64, and now we have 1, 10, 32, 32. Now, why is that? Well, let's go back into the CNN explainer, jump into this MaxPool layer here. Maybe this one because it's got a bit more going on. Do you notice on the left here is the input? And we've got a 2x2 kernel here. And so the max pooling layer, what it does is it takes the maximum of whatever the input is. So you'll notice the input is 60-60 in this case, whereas the output over here is 30-30. Now, why is that? Well, because the max operation here is reducing it from section of 4 numbers. So let's get one with a few different numbers. There we go, that'll do. So it's taking it from 4 numbers and finding the maximum value within those 4 numbers here. Now, why would it do that? So, as we've discussed before, what deep learning neural network is trying to do, or in this case a CNN, is take some input data and figure out what features best represent whatever the input data is and compress them into a feature vector that is going to be our output. Now, the reason being for that is because you could consider it from a neural network's perspective is that intelligence is compression. So you're trying to compress the patterns that make up actual data into a smaller vector space, go from a higher dimensional space to a smaller vector space in terms of dimensionality of a tensor. But still, this smaller dimensionality space represents the original data and can be used to predict on future data. So that's the idea behind MaxPool is, hey, if we've got these learned features from our convolutional layers, will the most important patterns stay around if we just take the maximum of a certain section? So do you notice how the input here, you can still see the outline of the car here, albeit a little bit more pixelated, but just by taking the max of a certain region, we've got potentially the most important feature of that little section. And now, of course, you could customize this value here. When we create our MaxPool layer, you could increase the kernel size to 4x4. What do you think will happen if we can increase it to 4? So here we've got a 2x2 kernel. If we increase it to 4x4, what happens? Do you notice that we've gone from 62 to 15? We've essentially divided our feature space by 4. We've compressed it even further. Now, will that work? Well, I'm not sure. That's part of the experimental nature of machine learning, but we're going to keep it at 2 for now. And so this is with our tensor here, 64, 64. But now let's do the same as what we've done above, but we'll do it with a smaller tensor so that we can really visualize things. And we're going to just replicate the same operation that's going on here. So let's go here. We'll create another random tensor. We'll set up the manual seed first. And we're going to create a random tensor with a similar number of dimensions. Now recall, dimensions don't tell you, so this is a dimension. 1, 3, 64, 64. That is a dimension. Now dimensions can have different values within themselves. So we want to create a 4-dimensional tensor to our images. So what that means is, let me just show you. It's way easy to explain things when we've got code. Is torch.randn, and we're going to set it up as size equals 1, 1, 2, 2. We can have a look at this random tensor. It's got 4 dimensions. 1, 2, 3, 4. So you could have a batch size, color channels, and height, width. A very small image, but it's a random image here. But this is quite similar to what we've got going on here, right? 4 numbers. Now, what do you think will happen if we create a MaxPool layer, just like we've done above? Create a MaxPool layer. So we'll go MaxPool layer. Just repeating the code that we have in the cell above, that's all right. A little bit of practice. Kernel size equals 2. And then we're going to pass the random tensor through the MaxPool layer. So we'll go MaxPool tensor equals MaxPool layer, and we're going to pass it in the random tensor. Wonderful. And then we can print out some shapes and print out some tensors, as we always do, to visualize, visualize, visualize. So we're going to write in here MaxPool tensor on a new line. We'll get in the MaxPool tensor. We'll see what this looks like, and we'll also print out MaxPool tensor shape. And we could probably print out random tensor itself as well as its shape as well. We'll get the shape here, dot shape, and we'll do the same for the random tensor. So print, get a new line, random tensor, new line, random tensor, and then we'll get the shape. Random tensor shape, random tensor. Oh, a lot of coding here, but that's the fun part about machine learning, right? You get to write lots of code. Okay, so we're visualizing what's going on with our random tensor. This is what's happening within the MaxPool layer. We've seen this from a few different angles now. So we have a random tensor of numbers, and we've got a size here. But the MaxPool tensor, once we pass our random tensor through the MaxPool layer, what happens? Well, we have 0.3367, 1288, 2345, 2303. Now, what's the max of all these? Well, it takes the max here, is 3367. Oh, and we've got the random tensor down there. We don't want that. And see how we've reduced the shape from 2 by 2 to 1 by 1? Now, what's going on here? Just for one last time to reiterate, the convolutional layer is trying to learn the most important features within an image. So if we jump into here, now what are they? Well, we don't decide what the convolutional layer learns. It learns these features on its own. So the convolutional layer learns those features. We pass them through a ReLU, nonlinear activation, in case our data requires nonlinear functions. And then we pass those learned features through a MaxPool layer to compress them even further. So the convolutional layer can compress the features into a smaller space, but the MaxPooling layer really compresses them. So that's the entire idea. One more time, we start with some input data, we design a neural network, in this case a convolutional neural network, to learn a compressed representation of what our input data is, so that we can use this compressed representation to later on make predictions on images of our own. And in fact, you can try that out if you wanted to. Click here and add your own image. So I'd give that a go. That's your extension for this video. But now we've stepped through the MaxPool2D layer and the Conv2D layer. I think it's time we started to try and use our tiny VGG network. This is your challenge, is to create a dummy tensor and pass it through this model. Pass it through its forward layer and see what happens to the shape of your dummy tensor as it moves through conv block 1 and conv block 2. And I'll show you my trick to calculating the in features here for this final layer, which is equivalent to this final layer here. I'll see you in the next video.